Okay, this is what all of my solutions looked like here for the problem number 1. Hopefully those look good to you. Now, one thing that the problem had in common here, all of the first values on these x values were 2, which means on our graph we were finding the slope of the line that connects two dots, with the first dot being 2, 27. If you have to do that over and over and over, like we had to do it 8 times here, this expression will perhaps simplify or shorten this process. What this says is this: calculate the average rate of change for the toy car from the second to any second past 2, which looks like 2 plus h, which is weird. So for example, if I were to draw my own graph here and show you what we're looking at, we have our parabola. 2, 27 is right here. If you were to pick any point that's beyond 2, I'm just going to make a dot. You'll notice I didn't label the x-axis here. That guy can be anything I want it to be. It could be there, etc. The distance that we went past 2 to mark it, to get to there, this distance right here is called h. It's arbitrary. It's anything we want it to be. So the h just basically means it's a number that we get to control, which now makes this end destination, or this guy right here, have an x value of 2 plus h. So if we were to write these coordinate points right now, because that's what we have to do, this guy right here is still 2, 27. The 27 comes from plugging 2 into that equation. And this random dot, this dot which I could have put anywhere I wanted to, is 2 plus h, comma, something. The question is, what is that y value? Well, if you think about what we did to get the 27 for the 2, we took the 2, we plugged it into that equation, the 6t squared plus 3 thing. So now I have to stick 2 plus h in for that t. And if I wrote that exactly as I said it, it would just be that. It's very ugly, but this is just any coordinate point past 2. That's all this means. So the average rate of change is the slope of the line that connects two dots. We need to find the slope of the line that connects these two dots. So we're going to do difference of the y's over difference of the x's. Start with the big y. In this case, we're going to start with the ugly y. That's this guy. So we do 6, 2 plus h squared plus 3 minus, in this case, the pretty y, 27, all over ugly x value minus the pretty x value. So this process is the exact same as doing difference of the y's over difference of the x's that you did up here 8 times, but it's much uglier because we still have variables in here. It's our job now to tidy this up as far as it'll go. So we have to FOIL 2 plus h squared, which is going to get us 4 plus 4h plus h squared. What do you see happens on the bottom? That 2 and that 2 cancel, so that we just have an h on the bottom right now. Let's keep going. We got to distribute that 6. So I see 24 plus 24h plus 6h squared plus 3 minus 27 all over h. And start simplifying. That 24 plus that 3 is 27, minus that 27 all cancels. And you'll notice the thing that's left here on top, we can factor. We can pull an h out of that. We could actually pull a 6h out, but we don't need to, because all we want to have happen is that h right there get canceled. So if I pull the h out, cancel it, the stuff that's left over is an expression. This expression right here will allow you to find the slope of the line, which is the AROC, for any 2 points on this graph, as long as the first one is 2, 27. So, what you're going to do down below right now is use that expression. Here's how it works. First, you have to identify what the h is in the previous coordinate points. But the h, keep in mind, is the distance from dot that started at 2, 27 to the second dot. It's the x value distance between these two. What is the distance from 2 to 3? The distance is 1 unit. So the h value is 1. Now that you know the h value, you can figure out the average rate of change using this expression. Remember, this is an expression that'll find the slope of the line that connects any 2 points as long as the first one is 2. Since we're using the 8 above that all start at 2, it'll work. So once you identify what the h is, you just plug it into this expression. So it becomes 24 plus 6 times 1, which is 30. And 30 feet per second is what we got up above by doing the calculation of difference of the y's over difference of the x's. On B, go identify what the h is. So we're looking at the distance from 2 to 5. The distance from 2 to 5 is 3. Plug 3 into your new expression. You'd have 24 plus 18. And 24 plus 18 is 42 feet per second. So this expression will work as long as all values start at 2. All coordinate points started at 2. This one here would be a 4. 4 to that guy would get you 48, etc. Now, instead of being lazy, you should keep checking these just to make sure that your solutions from above were correct and you didn't have any calculator errors or something like that. So keep finishing these and confirm that they work with doing it the long way.